Hey guys, welcome back. Today we're going to be solving LeetCode 167, which is 2 sum 2. And the key phrase here is the input array is sorted. Feel free to pause the video just to read through what the problem is asking, but I find the examples more descriptive. So suppose we were given an array, numbers in this case, and it's something like this. So numbers is something like 2, 7, 11, 15. And keep in mind that in this example it says the array is 1 based. It's 1 based, not 0 based, meaning the first element isn't 0, it's 1. So this is index 1, this is index 2, index 3, and index 1. Okay, so we want to find two numbers that add up to a given target. And in this case, in this first example, our target is 9. So I'm going to write t equals 9. Okay, and it's guaranteed there is going to be a solution. So the way to solve it first is to initialize 2 pointers. Okay, a left and a right pointers. Right pointer starts off at the end, left pointer starts at the beginning of the array. Okay, and then at every iteration we check the left plus the right and see. So for instance, in our first iteration we're going to check our first, which is 2 plus 15. Okay, and this happens to be equal to 17. Okay, is 17 equal to 9? No, 17 is greater than 9. So meaning we have to shrink this sum. We have to shrink it because it's greater than our target, and the only way to shrink it is by moving the right pointer, not the left pointer. If we move the left pointer to increase the sum, we move the right pointer to decrease the sum. So we move our right pointer from 15 to 11. Okay, then we try to compute it again. So we go back and say, okay, our numbers now are 2 plus 11. 2 plus 11 is 13. Okay, this is obviously still greater than 9. So again, we want to shrink the sum. Only way to shrink it is by moving the right pointer. We move the left to increase it. And now we're right, the left and the right pointers are next to each other. Keep in mind they can never be equal to each other. So this better be our final answer. So let's check it. So 2 plus 7, what is that? That is 9, which is exactly our target. And in this case, we're gonna go ahead and return. Remember, this is a 1 based index, not 0 based. So we return 1 because that's the index of 2, and then we'll return 2, which happens to be the index of 7. And this is our final answer. So as always, let's go ahead and code up this solution. Okay, so like we said, the first thing we do is define our left and our right pointers. And this is standard. Every time you see sorted array, think binary search. So left and right is pretty standard. This is 0, left is 0, right is just the length of our input array, which in this case is numbers, minus 1. Okay, so now we have our left and right pointers. So while L is less than R, remember we said L can never be equal to or go past R. Okay, so while this is, what do we want to do? Let's create a variable called 2sum, which is going to keep track of the calculation of it. And 2sum is just going to be numbers of L plus numbers of R. We're just adding up the left and right pointers. Okay, so now a couple of checks. If 2sum is greater than our target, just like in our example, if it's greater, obviously we want, since it's a sorted array, we want to move the right pointer inward. So the right is just going to be equal to the right minus 1. If he's less, okay, if he's less, in that case we want to move the left pointer, right? Want to move the left pointer 1 inward. Now the last check is they are the same, so we can use the else statement, or to be honest we can use a second elif. I choose to use elif. Elif, they're equal. 2sum is right on our target. Okay, we just want to return. Again, we're guaranteed there's a solution, so we don't have to do any error checking. Okay, and also remember it's 1 based, so that's why we're adding 1 to the left and the right pointer. So let's go ahead and run this code and see what it tells us. Okay, accepted. Let's go ahead and submit it. We're in the 64.50 percentile in terms of time complexity, and space complexity is not that bad. So that's it for the video, guys. I hope it was helpful, and I'll see you guys in the next one.